Hello, everyone.
Hello.
Hope everyone are doing fine.
Yes.
Awesome. Okay. So we had some of the topics covered yesterday on CCNA. So we'll be proceeding with the rest of the topics today. And I think we have some of the participants still joining. That's okay. We can get started. So before moving on, I think I missed to tell you yesterday. Have you guys ever seen the syllabus of CCNA and CCNP? Have you guys gone through the syllabus?
Yes, I have.
Yes.
Yeah.
Mrigank. Okay. Okay, that's good. So this is the syllabus that you're seeing in front of your screen. This is the syllabus actually. So different units will have different weightages. Okay, it'll have different weightage. So we actually started with introduction yesterday. Today we are starting with network fundamentals. Then we'll proceed with network access. I mean, these are just the main topics. We just have subtopics inside this as well. Okay. So these are the portions that we have to cover. All right. So just in case if you lose track or if you're wondering what is happening or which part are we covering, this is the topics that we have in our syllabus. First one is introduction, network fundamentals, preceded with network access, then comes IP connectivity, then IP services, then IPv6, then security fundamentals, then network management, network design, automation, and programmability. Okay. These are the topics that we have. And if you don't mind me asking, can anybody, Amir, let's call out a name. Amir, are you able to hear me?
Yes, I can hear you.
Okay, awesome. So just a random question, Amir, just because you're you're the first name in my list. Sorry, don't mind. So do you remember what happened yesterday, or were you there in the class yesterday?
No, I wasn't.
Okay, is there anybody who can tell me that what we discussed yesterday? Anybody? Manoj, Salim, Nandan? Anybody aware of what we did yesterday? Any topic that you remember, that would be fine.
No, I have not done it.
Sorry, you were not there yesterday?
No, no, this is my first.
Yes.
Okay, awesome. So I saw Yuva Vijaya Prashant yesterday also because of the letter Y. Your name always comes at the
Yes,
last,
yes.
and I see you yesterday. So can you let me know any one of the topics that we discussed yesterday? Do you remember any
Uh,
one of the topics?
7 layers,
Awesome,
OSI model or 7 layers.
awesome. That's good. That's right. Okay, and after Yuba, can you name anybody who was in the class yesterday? Do you remember anybody in the class yesterday?
No, sir.
No? Anybody else who was there yesterday? Okay, no problem. So today's class, just letting you know. So I'll just explain the concepts to you, and in between, I'll just after 15 minutes or 20 minutes, I'll just take a small break and start asking questions. In the sense, don't worry about the questions. It's just not like exam. I'll just try to find out if there is any doubts from your end or the way that you have understood. I'm just trying to make sure that the way you have understood is fine or no. That's it. It's not kind of exam or something. I'll just take a break after 15 minutes and start asking questions. So if there is any doubts, you can start asking questions right away, or once I ask you questions, I'll get to know that. Okay. All right. So let's get started. So yesterday we just ended up. So just a brief idea about what we did yesterday. Yesterday we started with something known as IP addresses, right? And also we started with something known as classes in IP addresses, right? Basically, what I was speaking yesterday is network fundamentals. This portion, network fundamentals. This network fundamentals, under this one, we have a subtopic. What is the subtopic? Introduction to OSI model, introduction to IPv4, that is Internet Protocol version 4. Okay. We were talking about IPv4 yesterday. Okay. Let's continue with IPv4. Now, let me come back to IPv4, assignment of IP address. Brief idea. I told you that an IP address is a 32-bit address, right? 32-bit address in the sense, when you write 32-bit, you know that each bit is, what is a bit? Anybody, any idea? What is a bit? Yeah,
2 bits.
that's right. Thank you, Nandan, at least for trying to answer. That's right. So a bit is nothing but a 0 or 1. Okay. A bit is nothing but a 0 or 1. An IP address is represented by 32 bits, in the sense 32 times 0 or 1, just like this. Okay. So 32 bits is not written continuously. Okay. Continuously. All these 32 bits are not written continuously. Okay. Then how they are written? They are written in 4 blocks of 8 bits. So every 8 bits are made as one block. So equally divided into 4 blocks. Okay. That is how an IP address is written. Now, this is the IP address that a computer language will understand in binaries, zeros and ones. But what about human beings? What about human beings? They do not understand this language. Exactly. So somebody has also mentioned in the group saying decimal to binary conversion, history of switch and computer connectivity, each vendor's protocol. That's right, Manoj. That's right. So that's the thing that we discussed yesterday. Very good. Thank you. So it is classified into 4 blocks of 8 bits. 8 bits together, we call it as octet or a byte. Just remember this, guys. Okay. Now, this is computer readable language. Human readable language is 192.168.1.1. This is easy for humans to remember. Now, let's convert the same. Let's convert the same. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Anything written in binary will be 2 to the power of. Okay. 2, 4, 2 power 5, 2 power 6, 2 power 7. What is 2 power 7? 128. 2 power 6, 64. 2 power 5, 32. 2 power 4, 16. 8, 4, 2, 1. Okay. Now, let's convert this 0, 0, 1, 0, 1, 1, 0. Okay. How to convert it? 0, 0, 1. So 1 is in the place of 16. So 16 plus 4, 20, 20 plus 2, 22. All right. You got the first one, 22, right? Now the second one, 0, 1, 1, 64 plus 32, which is 96, 96 plus 0 plus 8, 104 plus 1, 105. Write it as 105. Then 1001, 128 plus 16, which is nothing but 144 plus 8, 152 plus 2, 154. Okay. Last one, 1010, that is 101, 128 plus 32, 160, 160 plus 8, 168, 172, 174, 175, 175. So this is the IP address that you see. Okay. This is how you convert binary to decimal. All right. Now, just to make sure. So I'm actually trying to make sure if this looks correct or not. So only if I'm confident that you guys are, aware of things, I'll be confidently able to move on. So for that particular purpose, what I'll do is I'll have 3 or 4 binary to decimal conversion. I'll give it to you guys. I'll name those binary. I'll name you guys. I'll just give it to you. You just hold a pen and paper with you. Okay. Hold a pen and paper with you. Try to convert that. Even if you're not able to do that, that is still okay. I'll be explaining that to you. Once you say no, you're not able to do it, I'll just explain it to you again. Just give it a try. Just giving it a try is not a problem. Just give it a try. And also yesterday I explained to you that an IP address, apart from writing in decimal form, why? Because to make it convenient to the humans, apart from that, we have divided the IP address into 4 classes. What are those 4 classes? Class A, Class B, Class C, and Class D. Why we have divided into 4 classes? Because we want different number of hosts in different networks. In Class A, I have one network portion, and 3 host portion. Right? That is the default behavior of Class A. In Class B, I have 2 network portions and 2 host portions. Awesome. In Class C, I have 3 network portions and 1 host portions. Now, let's calculate how many hosts are in Class A. So it is 8 bits here, 8 bits here, 8 bits here. So 2 power 8 plus 8 plus 8. 24. Almost 16 million. Now it is how many hosts here? 2 power 16. That is 65,536 number of hosts. What is host? Host is nothing but the IP address that you can assign to computers or printers or any devices in your organization. So that number of 65,536 IP addresses will be available to you so that you can assign it to your computers, printers, and so on. Here, 2 power 8, because host portion is only 8 bits. So it is 256 only. You will get only 256 IP address. 256 hosts can be assigned here. Okay. That's the funda. That's the reason they have divided an IP address into 4 classes. 4 classes. So they might ask you in the exam also, guys, why is an IP address divided into 4 classes? Always remember, because every network has its own requirement. Okay, its own requirements. Let's say my office is a small office. I need a small network. maybe with only 32 users, 32 hosts. Only that much is needed, or only 250 hosts. Okay, only you need 250 hosts. What do? You take a class C, because class C only 256 is enough. If you need more than 65, 66,000, you take class B. If you need more than that, if you are a big company like Google, take class A IP address. Okay, as simple as that. That's the reason they divide it into different classes. Okay, that's the idea behind the classes. We'll talk about the subnet mask in the coming section. You know that there are 4 classes. 0 to 127 is class A. 126, this becomes 126. 127 is reserved for loopback address. So when you ping from your computer to a loopback 127.0.0.1, you will get a reply back. So by getting the reply, what do you feel? You feel that your connection is stable. The IP address that you have assigned to your computer is stable. That is the reason you're getting a reply from the loopback. Okay, to make your connection, to check your connection, a loopback is always used. 128 to 191 is class B. Okay, 128 to 191. Now, class D and class C, as mentioned on the screen. Now I have a small task. Okay, guys, let me actually take Yuva. Would you be okay with that? Can you hear me, Yuva?
Sir.
Okay. A small favor I would like you to do. I want you to convert a few into decimal. Would you be able to do that? I'll let me assign you this 192.168.1.1. Would you be able to try this?
Yeah.
Let's see. Let's give it a try. I'll keep it on the screen as well. Okay. 192.168.1.1. Can you write it in binary form how 192 will look? I'll write the 2-part table also so that it will be convenient to you. So how do you write 192? So 2 power 7 is 128, 64, 32, 16, 8, 4, 2, 1. Exactly. Now, how do you write 192? Put 1 in place of 128 and put 1 in place of 64. So 128 plus 64 is how much? 192. Right? Rest all 0. Right?
Yeah.
So it is 1100 0000. Simple. Okay. Similarly, 168. Let's try 168. How would you write 168?
1.
Okay, 1. If you add 64, it will become 192. So I'll do 0.
0.
Okay. Yes, that's right. 128 plus 32 is how much? 160. Right?
Yeah.
160. So I'll add 1 here. Okay. 160 plus 16 is 176. So it'll be 0 itself, right?
Yes.
Okay. And should I add 8? Your sum is already 160 now. If I add 8, it will become 168.
168.
Okay. So 1. So 10101 000. Right? How do you write 1 in decimal? Sorry, in binary.
0.
Only the last should be 1. That's it. Right? So it is 0000 0001. Okay. Similarly, the last one is also 0, 0, 0, 0, 0, 0, 1.
0, 0, 0, 1.
That's it. Okay. Don't mind I asked you. I just want to know that where you stand so that I can explain deeply, or I just can,
Oh,
go
okay.
at the surface level. That's it. Okay.
Oh, okay.
Thank you. Thank you so much, Yuva.
Okay. Thank you.
Okay. Second one, would anybody be able to do it? 172.16.1.1. Anybody? Manoj, can you do it? Okay. Oh, Mrigank and Manoj has already pinged it. Awesome. Awesome. 1100. Yeah, you got it. Manoj, can you do that 172.16.1.1? I'm on duty, that's why I'm chatting. No worries. No worries, no worries, Manoj. So Mrigank, okay, Rakesh has sent it to us. Rakesh. Oh, that's nice. Mrigank, can you do 10.85.13.1? I think Rakesh has sent the answer for 172.16.
Yeah. So for 10.85 will be first octet will be 0, 0, 0, 0, 1, 1, 0, 0.
1010.
Yeah, all four zeros, 1100. That's the first octet. What's the next one? 10 dot. What was the IP?
It is
10.85.
10.85.13.1.
Yeah. The second one would be 0, 0. So 128.00.64.1.
Here's the table if you want.
Yeah, I'm just writing that.
Yep.
It's 10.68, right? You mentioned
10.85.13.1.
10.85.
10.85.13.1.
680. Yeah. 30. Posting it in the chat.
Okay. Okay. 10.85.13.1. Just to show you guys, okay, 10.85.13.1 and 2 power 7, 2 power 6, 2 power 5, 2 power 4, 2 power 3, 2 power 2, 2 power 1, 2 power 0. Okay, 128, 64, 32, 16, 8, 4, 2, 1. Just double it or reduce it by 2. Okay, divide it by 2. Okay, Mrugank, awesome. That's right. Okay, I think a small mistake. Let me check that. So 10 is written as 0, 0, 0, 0. 8 is 1. 4 is 0. 1, 0. Is that right,
Sorry.
Mrugank?
Yeah, I
That's
misplaced.
okay.
But I
That's
know
okay.
the logic actually.
Yeah, that's
I
good. That's good. I
already
know
got
it happens actually. Because of a confusion maybe. So okay, the next one, 85 is written as 1 in place of 64. So 0, 1, and then as Mrugank has written 0, 1, 0, 1, right? That's right. Then okay, this is 85 because 64 plus 16 will give you 80. Then 4 plus 1 will give you 5. That is 85. 13, obviously, all the upper digits are 0, 0, 0, 0. 8 plus 2, 8 plus 4 is 12. Then this is 13. So it is 1, 1, 0, 1. Okay. Then 1 is written as, obviously, you know this, 0, 0, 0, 0, 0, 0, 0, 1. Okay. That's about decimal to binary conversion or binary to decimal conversion. Sorry to if I'm stressing on this more, because once you know this clearly, the further subnetting concepts, when we get into subnetting concepts, that becomes little easier. Okay, that's the reason we are actually, even if you know I'm actually going into these decimal form and binary form, even if you know this, I'm sorry if it is a repetition for you, but just making sure that you have it in your mind while subnetting, because subnetting actually, people say that subnetting actually causes some confusions. So when you're good with decimal and binary, while teaching subnetting, it will not be a problem to you. That's the reason I'm going go over it more and more. Okay, now, to keep in mind, there are three classes. I already told you we have three different classes to work with: class A, class B, and class C. Okay, now, how do you identify? Now, there is something which I have to tell you, which you have to know regarding the IP address. Now, you have also learned what is a class A IP address. Okay, class A, if the first digit, okay, you have x dot x dot x dot x. Okay, you know that an IP address is written like this. You already know an IP address is written like this, right? And this is 8 bits, this is 8 bits, this is 8 bits, this is 8 bits, total of 32 bits. You already know that. Okay, now, how do you define if it is class A or not? You always see this first octet. If the first octet is within 0 and 126, okay, within or 0 or 126, then you decide it is a class A, right? Similarly, 128 to 191, class B. 192 to 223, class C. Then 224, 239, class D. 240, 255, class C. That is how you decide. Okay, let this class be in your mind always. Okay, this is how you decide class A, class B, class C, class D. Now, having that in mind, tell me if this belongs to which class. Tell me this belongs to which class. Anybody?
Class C.
That's right, exactly. What about this one?
Class B.
Exactly. And what about this one?
Class A.
Awesome, awesome. Okay, I think you're good with the classes also. I hope everyone else is also following along with us. Okay, so you already know which is class A, class B, class C, class C. Now, Mrugank, you told me, he just told me that this belongs to class C. Okay, now I want to ask you guys again, Mrugank, I want to ask you or anybody who is able to answer, which is this class? Class C, right? Class C, as you told me. Now, a computer with this IP address, with class C IP address, same IP address, what I've written above, is connected. Okay. I have another computer. Okay. And they are connected through a wire. Okay. Now, will they be able to talk? I have two IP address written on one computer, another computer. Okay. And Mrugang told me it is class C. Okay. Will they be able to talk to each other? Will 192, 168, 1.1 be able to ping 1.2?
Yep.
Mrugang says
Yep.
it is possible, right? Why? Because
they are in the same network.
exactly. Okay. Now we're discussing something known as same network and different network. Now, how do you find out if it is in the same network or different network? You know that in class C, there are three network portions and one host portion, right? First three are the network portions. Next one is the host portion. First three are network portion, last one is the host portion. As you can see here, the network portion of these two IP addresses are the same, right? They are the same. Only the host portion, is different, right? Only the host portion is different. So they are the two hosts of the same network. They are the two devices of the same network. So they belong to same network, right? Hope you got that. Similarly, another example I'll give you. Okay. I'll take a class A example. Now let's say these two IP addresses are assigned to these two computers which are connected to each other. What can you say about these now? Are they in the same network or are they in a different network?
Same network.
Exactly. Why same network? Because when you see /8 is the default mask of class A. Okay. And always you observe the first octet. First octet, always see it is a 10 dot network. So obviously 10 dot network belongs to class A, right? And /8 also is a class A mask, right? So in class A, what happens? There is one network portion, three host portion. One network portion, three host portion. As you can see, compare both the IP addresses. What do you find? You see that network portion of first IP address and network portion of the second IP address both seem to be the same. So these two computers are in the same network. When they are in the same network, not only unlike you and me, I mean, like you and me, even the computer checks the network, checks the IP address, and checks the destination IP address. First, it checks the source IP address, then it checks destination IP address. When I say on computer 1, ping the second IP address, which is 10.221.220, forgive my handwriting, guys, .5, when I say ping on this computer, it first checks the source IP address. My IP address is 10.223.6.1/8. Even that is /8. So both are on the same network. I don't need to go to the default gateway. You know the behavior of computers. Whenever it finds that the destination IP address is not in the same network, it will always go to the default gateway, right? It will always route the packet to the default gateway. But here it compares source and destination. Source and destination are in the same network. So it knows that it is in the same network. What happens? It sends the packet to 10, 221, 220, 5, 8. Okay. That is how you come to know if it is in the same network or different network. All right. So that's about this same network. This is just a slide, but you can compare many IP addresses like that. Okay. You can take a couple of IP address. For example, let me write down some other IP address as well. Anybody else apart from Rugang can answer this if you're interested. Let's say anybody else? Anybody's name I have to pick? Narendra or Syed? Anybody can answer this? Are these two in the same network? Narendra, Syed, or I think Manoj is in the middle of work, so he's just able to ping.
Yeah, both are in class A.
Awesome. Awesome, Sayed. Thank you. And apart from Pranav, did you understand this? Are you able to figure out which?
Yeah, got it.
So can you make out what these two are? Are they in the same network?
No, that's 172.16.0.1. That's a class B, and 192.116.0.1 class C.
Awesome. Awesome. Thank you, Pranav. So that actually that actually it's not actually guys, I'm actually not testing you. I just want some confirmation that if I can actually move on to the next topic. That's it. Sorry if I'm bothering you by questions, but that's the motto behind it. Anyways, let's move with the next topic. Okay, now let's go with say yesterday I showed you this probably. So when you have to check on your own computer, if you have to check what is the IP, you type in ipconfig, and also when you look at the subnet mask and default gateway is always used when the computer, you go to your computer and type Google in the sense, Google, you don't type Google's IP address, but it goes to DNS server, it gets the IP address of the Google, and then it will go to the Google server. Google, let's say it is, say, some 11 dot network, or let's say you're pinging AT&T with 12 dot network. Okay, when you say 12 dot network, then always the computer checks the source IP address and destination IP address, just like how I told you 2 minutes ago. If it is in the different network, always the computer routes to the default gateway. Okay, this is a thing to remember. When you don't have that IP address, when you computer sees that it's not in the same network, it is always routed to the default gateway. Okay, this is about the same network and different network that we were talking about. So class A, class B, and class C, these are the things that you will see. Network portion, just to, I added a picture here so that usually for people, picture actually stays in the mind more than words. So I just added a picture here. So network portion is of 8 bits, rest is 24 bits for class A, for class B, and class C. Okay, since you guys are good with classes now, I think I can move further. Let's move on to something called as private and public IP address. So just like class A, class B, and all that, we have in the IP address. So all the topics that we were talking about right now before this was about IPv4. IPv4 classification in IPv4. What all classification we saw? We saw that an IP address is classified into network portion and host portion. We also saw that an IP address is classified into classes like class A and class B, class C, class D, class C, and we saw what purpose it was. Okay. We also saw that. And also we saw that an IP address comes with a subnet mask also. I'll tell you what a subnet mask does also in few minutes. Okay. Further, an IP address is also classified as private and public IP address. Okay, it is also classified as private and public IP address. Now, what do you mean by private and public IP address? Let's say I have my own company. Okay, I have a switch, my own organization. I'm not connecting to any internet or anything. I just want files to be moved within my users only. Okay, my workers only. And this is connected to a router. Router is connected to a service provider, internet service provider. Okay, let's say this is some gateway for all the computers if they need to go out. 192.168.1.1. Let's say this is 1.2, 1. 1.3, 1.4, 1.5, and 1.6. Okay, they are all in the same LAN. If they're all in the same LAN, if all the computers are in the same LAN, exchanging information from one computer to another computer is not a problem at all. It is not a problem at all. If 1.6 has to send an information to 1.5, it directly goes through the switch and sends it out. And here it is sending to 1.3 as well. Okay, there is no problem at all. Okay, so here inside the LAN, inside the same LAN, you're not in the public infrastructure. Okay, you're not in the public network. It is your own network. Okay, you can give any IP address. You can use the private IP address. What are the private IP address? Private IP address is something which is not recognizable on the internet, which is not recognized on the internet. Even if on the internet, if you go to a computer and say on the internet 192.168, if you use this private IP address, it does not know where to route to because it is a private IP address. It is not a routable IP address. Okay, no routers in the internet will have 192.168 assigned. Okay, because they are not globally routable addresses. Apart from these private IP address, you can use any IP address and that is globally recognized on the internet. So private is not globally recognized. Recognized, not routable. Only can be used in LAN. Okay, it is only used in LAN. LAN in the sense inside your network. Inside your network. Once you go out of this router, then you're not inside your network. You are in a public network, right? In public, it is public IP address recognized globally. When you say 11.network, it is recognized. 12.network, yes, it is recognized. Okay, all the recognized IP addresses are known as public IP address. And it should not be used in the LAN, not in LAN. Okay, and these are globally routable addresses. Why do we use private IP address? Now, if you give every computer a public IP address, every computer, if you give a public IP address inside your own organization, we will be running out of all the public IP address that we have very soon, because we know each company has thousands of computers. Of course, no doubt. Every company will have thousands of computers. I mean, medium-sized company, of course, they'll have around like 1,800 to 1,000 workers for sure. Every company is getting around 800 to 1,000 IP addresses, public IP addresses. Then we'll be running out of all the public IP addresses soon. So that is when they got this concept as private IP address and NAT solution along with it. Okay, using the public private IP address inside your organization is fine, and while going out you have to do a NAT. What is NAT? Network address translation. Anyways, I'll be explaining that to you in in our future classes. While going out of the organization, you use a NAT. Now, NAT in the sense from converting from private IP address to public IP address. That is known as network address translation. There are different ways how to do a NAT. Now, by this, what do you see? Here I'm saving the IP address also. I'm using private IP address. Now, it does not mean that if I use 192.168 in my organization, my company, let's say my company name is ABC, another company XYZ, he also can use the same IP address, 192.168 IP address in his computers, on his computers. And while going out, he can use any public IP 11 dot, 12 dot, or 223 dot, anything you can use, which is publicly recognizable. See how much IP, how many IP addresses this saves. This saves a lot of IP addresses. Let's say you have 1,000 computers. 1,000 computers are just given private IP addresses, 192, 168, or you have a private IP address in class A also. So this saves a lot of IP addresses. Okay. So the major difference between private and public IP addresses are private IP addresses are used on your local area network only. It is not used outside your local area network. Public IP addresses are used on the internet, right? Are used on the internet. Now, this is the IP address, private IP address range that you have to know. Okay. These are the private IP addresses range that you have to know. Excuse me. In class A, what do you see in class A? What are the private IP addresses that I can use? It is 10 dot network. 10.0.0.0 up to 10.255, 255, 255. Class B, 172.16.0.0 up to 172.130, 172.31, 255, 255. Class C, 192.168.0.0 up to 198, 192.68, 255, 255. Now, why have they introduced private IP address in different classes? There can be only one, no? In class A, they could, just give a private IP address and leave it. No, because in my company, I have only 16,000, maybe 1,000. Okay. Only 1,000 users. I can use this lowest network. Only these many hosts or IP address I need. I can use class B. I need little more, 2 power 16, 65,000 users. I can use this one. I need more than 2 power 24, 16 million computers I have, 16 million devices I have, 16 million workers I have. What do? Use the class A private IP address. That provides you more number of devices, more number of IP address. That's the concept. Okay. Moving on. Let's move to our broadcast and network address. I hope everyone are good till now. Any doubts till now? Pranav, Rakesh, Syed, Yuva, Manoj.
Yeah, all good.
All good till now?
Can you please explain that public and private again?
Yeah. So public IP address is nothing but the IP addresses that we use on the internet. Use on the internet in the sense it is something which a service provider gives you. Okay. It is an IP address which a service provider gives you. You cannot use a random IP address on the internet every time. You have to use only the IP address which is globally routable. Apart from this IP address, any routable IP address, if you use that, is a public IP address. Only these three IP address, the three ranges of IP address, these are your private IP address. Private IP address, to be remembered, always used only on your LANs, internal networks. Okay. It should not be used outside. Got it?
In the class C, we are saying that the first three are the network address.
Exactly.
Here it is 192.168.0.0. And
That's right.
second
So
is from 192.168.255.255. So it is in different network, no? Because 0 is in different network and 255 is in different network.
that's right. So I got your confusion. 192.168 1.1. 192.168 255.255. What am I writing? Now these both are in the different network, right?
Yes.
Exactly. I'll agree with you. But there are conditions, right? How? What is the condition? If I write it as /24, they both are in different network, right? What if I write it as /16? If I write it as /16,
Then it will be
/16,
of class B.
subnet mask will be of class B. So you will get two networks, two hosts. Now tell me, are they in the same network?
Now they are in same network, but
Exactly.
default mask is 255.255.255.0.
Yes. So we always don't use the default masks. Default mask is for the default class. The default mask will not be used every time. We actually manipulate the mask or use the mask according to our requirement. Now, coming to the concept of subnet mask, what is the subnet mask? Subnet mask actually tells us how many parts we're using as a network portion and how many parts we're using as a host portion. Okay. Now, what they are telling is, now they know that 192.168 is a class C address because it is starting with 192. I agree. What they are telling is, in class C, you can only use IP addresses from 192.168.0.0 up to 192.168.255.255. Up to that you can use, and that will be considered as internal network IP addresses only or private IP addresses only. You can use this 192.168.1.1 and 1. For example, I have two computers. Okay, this is my organization. Okay, imagine. Okay, I have two computers. On one of them, I have used 192.168 1.1 24 slash, second one 192.168 1.2 slash 24. Are they in the same network according to default subnet mask?
Yes,
Yes,
it is in the same network.
exactly. Now, how much are they allowing me? I can use another computer, 192.168.2.1. Now it comes in a different network, right? 2.1.
Right, it is in the 2.1.
Exactly. So what they are telling me is, like that, I can use 192.168.255.1. It is still in the different network, right?
Yeah, that is what I'm
Ex-
confused.
exactly. So in your company, it is not that you have to use the same network, right? So in 192.168.0.0 till 192.168.255.255, obviously they are not in the same network. They should not be in the same network because in your company also you have many departments: sales, marketing, accounts. One network assigned to one of them. So it is not necessary that all of them should be in the same network. For accounts, assign 192.168 1.0 network. For this, assign 100.0 network. For this, 250.0 network. Like that. They're just, it is just an IP address given by the standards or given by the organization to be used in our organization. Okay, it is the IP that you can use, whether it is in the same network or different network, that's okay. Even if it is in the different network, that is still okay. But this is a usable IP address. That is what they're telling. So if you want to assign, if you're doing any lab or anything, if you want to assign a computer any IP address, you can use these IP address, any of these IP address in this range. Even though it is in different network, that is still okay. Okay. So It doesn't mean they have to give the same network. They can give different networks also. You got it?
Limitation of the private IP addresses.
Sorry, can you repeat that again?
I said limitation of the private IP addresses.
Exactly. Exactly.
So these three IP addresses only used for our local LAN.
Local LAN. That's right. It can be used on our local LAN. On any computer you want, you can use. On any IP address. In this range, you can use any IP address. That's what they're telling.
But as I'm checking my office LAN, it is showing me that 221.134 something that IP.
Exactly. That is a public IP address. Right? That is a public IP address because it is in the office LAN. Right? When you see a 221, it is obviously a public. Right? Public IP address. Here, this is a private IP address. Office people.
So are we using public IP address in our LAN?
Yes, definitely. We can use public IP address in our LAN. So if you are sitting in your office, for example, let me ask you. So is it your computer which is showing as 221? Is it your computer IP address which is 221 address? Rakesh?
Still a little bit confused, but as you saying, there are limitation for the internet IP that I think public IP. Then how that organization use that 221 segment IP in our LAN? Because I think we are having more than 800 employees.
No, I didn't. Rakesh, I didn't understand your question. So your 221 IP address, is it on your computer or is it on something else? Where do you see that 221 address?
On my laptop.
So on your laptop, are you connected remotely or directly?
No, directly on my office, that LAN cable connected to my laptop.
Exactly. So when you're when you're going to command prompt like this, when you can see my screen now, when you're going to command prompt and say ipconfig on your computer, are you seeing that?
Yes. Here it is showing that 221.134.25.212.
Exactly. So that is been assigned. Your computer has been assigned, or for the application that you're using, it has been assigned a real IP address, a public IP address. It is not. That does not mean that everybody are assigned with 221 IP addresses. You can check with your neighbor's computer also. So there would be some particular team which is assigned with the real IP address, because let me actually draw the diagram and show it to you. See here. If this is your internet service provider, this is your organization, something coming in to your organization. In your organization, something will be in the DMZ zone, that is demilitarized zone. Some PCs will be in the demilitarized zone. Some PCs will be in the internal LAN. Okay. Not every PCs will be considered as an internal LAN. Why? Because there are some networks, there are some PCs where other outside guys also have to query and get a response to. Okay. Internal, what happens in internal network, only you are querying the internet and getting a response. So they are kept with a private IP address. So they are used with a private IP address. But for those which are used public IP address, from outside also there is somebody who is querying that computer and getting a response. That is why they are kept with a public IP address. If you keep private IP address here also for your servers, for your DMZ servers, email servers, for that also, if you keep a private IP address, then outside person, how can he reach your private IP address? He will not know your private IP address at all. So that's the reason they keep 221 or any IP address, any public IP address for those computers, especially for those computers, so that outside person also can access these particular devices. Did you get my point?
It's a little bit clear.
Okay. So
I have a
Thank you.
question, Rajiv. Sorry.
yeah, go ahead.
So here, the DMZ zones can still have a private IP address, but the router which you have drawn here, that's
Exactly. That blue.
external interface will have a public IP address. So DMZ server IPs will still be from the private IP address range.
So it can be a public IP address, but usually in the DMZ, we always keep a, especially when you keep an email server or any servers. If you keep a server in your DMZ and which is accessible by the, let's say your company is Mintra, your websites are being accessed. So let's say Mintra or I'm Flipkart. Okay. There is a server where I have to e-commerce website. Okay. I have to keep checking. Many users come into this server, hit this server. Now, if I have to go to Flipkart, if they have kept any private IP address, how can I reach them?
To destination NAT. Like we will be hitting
they
the
would
public
do
IP only.
they would do the
We will
NAT
be
while sending the traffic outside. They would do the NAT, but how will that particular router realize that when I am coming in, a random trafficking is coming in without even any outgoing traffic, a random new traffic is coming in? How they know that they have to NAT to the email server only? How do they know?
so there will be a NAT policy which will be mapping the
That's
public
right.
IP to the
That is
private
for
IPs.
exactly. That is policing is done for particular servers, not for these e-commerce servers. So if Rakesh is facing 221 or something, then he would be in such a zone that he is accessible by outside also. That is what I tried to say. So what you said,
Yeah.
Mrigang, you said that there is some NAT policy which is also for demilitarized zone. NAT policy done for some servers which are in the demilitarized zone, right? What I'm saying is these email servers, some email servers in demilitarized zone also have public facing IP addresses. Some also have private IP address. Some only have private IP address only on the router interface. They are given the public IP address, right?
Yeah, that's right.
So in his case, he would have been given the public IP address just because he would have been in the interaction side with the internet. That's the only reason. It could be that he would have given that. He would have been given that.
Or it might be that Rakesh, you are not connected currently to your organization. You are just doing, if you do a what is my IP, you might be seeing that public IP address because you are directly connected to your modem.
Oh, router, you mean, right?
Router, yeah,
Exactly,
IST
exactly.
router.
That
Correct.
could be another case, Rakesh. Because if you're not connected to your organization, just connected to your router means you also can get that IP. Check if
Okay.
you're
Oh, sure.
connected to your organization. Syed, you want to say something?
No, I think he has not checked his IP config, sir.
Oh,
Yeah, if he
Syed.
checked the IP config properly, we can come to know whether he has connected to internet or not.
That's right. That could be one of the cases also.
Yeah.
Did you do an IP config, Rakesh?
Yes, 1 minute.
Just go to your CMD and try a IP config. Let's see what you get. Because what used to happen is when I was in AT&T, so I also have worked with AT&T on some of the, so we were kind of a service provider, and mine was a outside facing computer which was doing all the security and configs. Okay, so I was actually given the 12.IP address. So if you check in IANA, which is Internet Assigned Numbers Authority, AT&T is given all the 12 IP address, public IP address. 12 block is reserved for AT&T. So I used to have that 12.2 assigned to my desktop. Those times we used to have desktop. only. So I thought in that way Rakesh could also been assigned to 21 address.
It's very unusual to have a public IP address
Exactly.
because it will be vulnerable to attacks and uh, DDoS or any kind of attacks from
Definitely.
outside.
Mhm.
So unless he's connected with his modem inside his house and he's doing what is my IP, he cannot have a public IP address. If he's connected to his organization, he will have a public IP address range from his VPN or stuff, whatever, but not otherwise. Or under the only special case which you mentioned, where he has an explicit machine which is dedicated for such services, which I don't think is the
Right.
case.
Right. Also, I think Syed actually mentioned the right point. Maybe he's just connected to Wi-Fi. Let's see what he replies back. Okay. In the meanwhile, while he comes back to us, let's proceed with the further. So, network and broadcast address. I think network and broadcast address. So, most of the people are aware of it, but I have to go through it. It's my job. So, let me actually go through this again. Network and broadcast address. So, in a range of IP address, if you are assigned with a range, okay, let's say you're given a range of, let's say 192.168.1.0/24. This is the IP address assigned to you. Then here, you 24 in the sense, 3 are network portions, 1 is a host portion. So 2 power 8 is the network portion. So 2 power 24 is the network portion, 2 power 8. Because this is 8 bits, this is 8, 8, 8, 24 bits. So 2 power 24, it comes around, 16 million something networks, and 256 hosts or 256 devices can be assigned. So range is 192.168.1.0 up to 192.168.1.255. This is the range. Now, what is a network address? Network address, when you put 0 after all the networks, after all the network bits, if you put a 0, then that is the network address. So the network address is 192.168.1.0. Now, if you put 255 after all the network bits, if you put a 255, it is a broadcast network ID, broadcast ID. So this is a network ID. This is a broadcast ID. Simple. Okay. That is how you actually figure out what is a network ID and broadcast ID. These two IP addresses cannot be assigned to any computers. Why? Because network ID just identifies what network a packet has to route to. Okay. It is there to identify what network a packet has to route to. Broadcast ID. Broadcast ID is nothing but used for if you send a broadcast to this particular IP address 192.168.1.255, then all computers in that particular network will receive that IP packet. That is why the broadcast is used. It's my office LAN, says Rakesh. Oh, okay. He has sent a screenshot also. Okay. IPv4 address. That's weird.
Yeah, I think he's just accessing internet. It's very weird.
That's right. Something very rare. I don't see this much often. Do do
Maybe for testing purpose, he might have connected to internet, his laptop. That could be the reason. That's it.
Local link IPv4 address by wireless connection. Okay, it's connected to his office LAN. I think it's one of the cases where similar to what I have worked, I guess. So I was
I I'm not very sure if it is the office LAN because it says in the Ethernet adapter SIFI. What I feel is
Oh,
that
that's right.
it is connected for local internet breakout from his office. He's actually just accessing internet. He will not be able to access any internal resources of his organization.
That's
Uh,
right. I think one of the cases with split tunneling, I guess.
yeah, it could be. It's split tunneling.
So when they actually do split tunneling, they allow office usage also and internet usage also. For some time, you'll not be able to use the office tasks. You'll be able to only access the internet. Maybe that's the case here, I guess. I'm not sure.
But split tunneling, you have dedicated subnets for
Exactly, yeah.
corporate
That's right.
networks, and only internet will be
True.
not through the tunnel. It will be outside the tunnel.
Outside,
Only
yeah.
local networks will be through the tunnel. So I think this is the case. It could be he's not definitely connected to his VPN. That's why he's getting this public IP.
True. Hmm. No, actually, nice that Rakesh is actually making us think about it, use our brains. Nice.
Yes, he has also given the screenshot of what is my IP, and that is the same IP as the
Uh-huh.
command line. So which suggests that he is definitely disconnected to the internet through whatever way his office is providing, either his Wi-Fi for guest access or something like that. Maybe. I'm not sure. Sorry, I'm just trying to also like appreciate this while thinking how it would be possible. So just giving my thoughts here. No
No
comments.
worries, no worries. Even actually, I'm also doing the same thing actually. So I'm actually looking at the screenshot and trying to see what else could be it. Sificorp.com DNS IP address also belongs to, yeah, DNS suffix also belongs
That
to
is my
Sifi.
company name, City.
Yeah, yeah, I know. So if DNS also belongs to it, then
SIFI is a net service provider, sir. Maybe that is why.
oh, okay.
He's working for ISP, I think. That is why he's on public IP.
Oh. Oh, it's a Sifi is a ISP, is it, Rakesh?
Yeah, it is. It is. It
Yes,
is.
yes, we are working in ISP as well.
Oh, okay. Got you.
That is why he's on public.
Okay. All right. And Rakesh, actually, when you work from home, also you get the same IP address.
I have not checked yet. This is the first time I am checking.
Just curious to know, Rakesh. Just when you work from home, also let me know. Check and let me know, Rakesh, what IP address you get.
Sure, sure. I will check and will update.
Thank you, man. Okay, so yeah, we've learned. So that was about the network and broadcast address. All right. So yeah, this is just a diagram of what I just told you. So just after the network portion, if you add a 0, that will become your network address. And after you add a 255, that becomes your broadcast address. This is a summarization.
Sorry, I'm disturbing again. I have one more doubt.
Yeah, go ahead.
You're saying that in my local language, saying that 192.168 0.1 is my LAN IP. I used in ABC, the ABC company,
Okay.
and the same IP, XYZ also use the same IP,
Yeah.
right?
Yes, exactly.
So how the two, if I want to communicate with that XYZ with the same IP,
Uh-huh.
then how will the
No,
communication?
Rakesh, that those are internal LANs. So when you come out of the router, so these, as I told you, these private IP addresses are there, no? they are used only inside the LAN. Once you come out of the router, they'll take the shape of a public IP address. So 192.160, any traffic coming out of 192.168.1.1 will become 221.10.10.1. It will not be 192.168 anymore. You got it? When it comes outside the router, just let me draw a diagram here. So even though you have 192.168.1.1 assigned here, let's say this is your computer. I have assigned 192.168.1.1 here. Okay. This is a switch connected to a router. Okay. And this is going to a service provider. And this is again a router, switch connected to a computer, let's say. Okay. This also uses 192.168. Okay, this is also using 168.1.1 in its internal LAN. Okay, this traffic when
Yes,
it goes,
this is the scenario. Yes.
traffic when it goes outside and goes to the router, it gets snatted to the public IP because this particular IP address is not recognized on the internet. This is the internet. Once you come out of your internal network, it is an internet. 192.168 address is not recognized on the internet. So it becomes, let's say 221.10.10.1. That IP address becomes 221.10.10.1. And it goes to, let's say 200.1.1.1, which is this router. This router will send it to 192.168.1.1 here. Okay. There would be a translation here, NAT translation. If you go to this router and say show IP NAT translation, you would have translation, whatever traffic which comes to 200.1.1.1, send it to 192.168.1.1. Here also, in this router, you will have whatever comes to 221.10.10.1, send it to 192.168.1.1. These translation will be in the router. So whenever 192.168 traffic goes, it hits the router, it will see the translation here. Okay, convert the IP address as source IP address as 10.10.1 and send the traffic. And here, okay, traffic is coming to 200.1.1.1, convert it to 192.168.1.1. Did you understand?
This translation is done at router end.
Exactly. The translation is done at the router end.
Okay.
But however,
So he keeps
Raj,
all the records.
Yeah.
however, Rahul, one thing of caution here, you are considering this case of 192.168.1.1 on both ends for two different companies, not
Two
in the
different
same company.
Exactly.
If it is a head office, and if the branch office has the same network, it will never communicate.
No, it will never
Correct.
communicate. So that is why
Yeah.
I'm telling you, it is an ABC organization. This is an ABC organization and this is a XYZ organization. If these both are same organization, then you will definitely not be able to communicate with each other because they are in the same network. It belongs to the same LAN. You can how the same way in your LAN, how you cannot give the same IP addresses to computers. Like that, in your organization, you cannot give the same IP addresses to two devices. Okay.
So it is for that also that in my just like someone just now said that my main branch office it has my main head office is at Chennai and I am sitting at Mumbai. So Chennai IP also will be the different or I cannot give the same IP.
If you are the same organization, then you cannot use the same IP address in the organization again. This
But the
192.168.
branches are
Sorry.
But the branches are different, so I cannot use the same IP to another branch.
No, that is not possible because you are the same IP address. So it is like, let me actually explain you in a better way. So you're sitting in the first floor, okay, of your house. You have given a computer the IP address of 192.168.1.1. You're all connected to a same cable. First floor, second floor, third floor is connected through a same cable. Just because you go to the second floor from first floor, second floor you got another computer, you cannot give the same IP address, right? Because it is all the same home. Got it?
Yeah, this is scenario is okay, but my concern is that if altogether different branch, it is one is at the Chennai and one is at the Mumbai.
That still comes under the
So
same domain. That still comes under the same enterprise network.
still it is at the same.
Mm-hmm.
Okay, okay.
Okay. Good set of questions. Thank you. So just to summarize, all the host bits to 0, set to 0 will give you the network address, and all the host bits set to 1 will give you the broadcast address. These two addresses are those addresses which cannot be used on your computers. Okay? Because these are broadcast and network addresses and which cannot be assigned to any of your computers. It won't take it. Next, let's see what's next I got. Okay. So the next topic that I have got is IP packet header. So till now, we actually discussed about the IPv4 Internet Protocol version 4. We discussed about this, its classes, the way it is divided into 4 blocks of 8 octets each, the way it is divided into public and private IP addresses. We all saw that. Now let's see how a header looks of an Internet Protocol packet. Okay. This is how the header looks. First, you will see a version, header length, type of service, total length, identification, IP flags, fragment offset, time to live, protocol, header checksum, source address, destination address, IP option, data. So these are the things that you see in your IP packet header. Okay. Now, each of them we'll just see what each of them does. Okay. What is the function of each of them? Now, version. What is the function of a version field in IP packet header? Now, can you see this division in between? This is nothing but a 16-bit boundary. Okay. Total, this is of 16-bit and this is of 16-bit. Okay. So the total length is 32 bits. Okay. The width, I'm sorry. The version field says what version of IP we are using. Now, if we are using IPv6, then it will be 6 here, but actually IPv6 does not have this header. It has a different header. So this particular header is only used for this IPv4. So usually you will, in this column or in this version field, you will see it as 4. Always you will see it as 4. Okay. Header length. What is a header length? The total length of the header. Okay. From here to here. From here to here, excluding the data I'm talking about. Okay. Excluding the data, the total header length is known as header length. It is also known as internet header length. Okay. Type of service. Now, usually you might ask me, what is the common length of a header, sir? The minimum length of an IP packet will be 20 bytes. Okay. 20 bytes. The minimum length. The maximum length can span up to 60 bytes because this field is of 4 bits. This is a 4-bit field. This is a 4-bit field. In a 4-bit field, let's say you have a 4-bit. 4 bits. Okay. 4 bits is 2 power 4. 2 power 0. 2 power 4 is how much? 60, 32. 32. 4-bit. Oh, I'm
Yeah,
sorry.
it should be 16. 16.
16, right? Yeah, sorry. 2 power 3 is 8. Yeah, it's 16. Okay. 16. And always this field, whatever written here is in the increment of 32. Okay. Whatever written here in header length field is an increment of 32. So it is a 32 into 16. I'm not sure what is 32 into 16. Let's see. Calculator. 32 into 16 gives you divided by 8. Okay, this field is now the minimum is 20 bytes. Let's say this is the header length. Okay, the minimum is 20 bytes. 20 bytes into 8 is 160 bits. Okay, 160 bits. So it is an increment of 32. So divided by 32 is 5. So the minimum value that you find on the header length field is 5 because it always is an increment of 32. So into 32 will give you the bits here. Similarly, 60 bytes. 60 bytes is the maximum. 60 into 8, 840. 840 bytes divided by 32. 32, 2s are 64, 200. 840. Not 32, it is 8. Sorry, 840 divided by 8. It is not 32. It's not even, no, 32. Is it 840? 8 6 are 48. Sorry, 480 it is. Okay. 480 divided by 8. 32, 6 8s are 48. So 480. 480. 480 divided by 8, which is 60. So the maximum possible is header length is 60. The minimum is 5. Oh, sorry. Minimum is 20 bytes. So for this, you get 20 bytes, the minimum header length. This is 60 bytes maximum. Okay. So we just have to remember that minimum header length is 20 bytes. Maximum header length is 60 bytes. Okay. Why 60 bytes if they ask you? Because 2 power 4. This is a 4-bit field. Okay. It is 16. 4-bit field. It is 16. 16 bits. 32. 16 8s. 16 8s. Oh, if it is 16, then 32 into 16, I guess. 32 into 16, which is 480. Okay.
128.
128. So what is the value? If it is 60 bytes, then the maximum value would be okay, it is 15 actually, not 16. Okay, 2 power 4. If we set all the bits to 4, this 8421. Okay, it is 15. Okay, that's the reason I'm not getting this. Okay, 8421. 8421. 2 power 0, 2 power 1, 2 power 2, 2 power 3. Okay, it is 8 plus 4 plus 2 plus 1, which is 15. That's right. Okay, that's the reason. So if it is 15, then yeah, 32 into 15. 32 into 15 will give you 480. 480 divided by 8 is nothing but 60. Okay. So the maximum possible is 15. Okay. 5 to 15. Header length varies from 5 to 15. Okay. Now IP flags. Now type of service. So type of service is something which is used in quality of service. Okay. Type of service in the sense, so if you're sending an video conferencing packet, or if you're sending a Cisco IP phone, you are having a Cisco IP phone, you're sending a VoIP traffic, you need that traffic to be prioritized. In that case, you use these kinds of fields, which is type of service fields. Okay. More on this, we have IP precedence and DSCP. Okay. That is coming under IP services. Okay. In unit 5, we can see that in unit 5, we'll talk about IP precedence. We'll talk about IP precedence and DSCP. Okay. There you'll know how to mark a packet as priority, how to mark a, IP packet as priority. Everything you'll see there. Now, what is the total length? Total length is the length of the header plus the data. Whatever the data you have plus the whatever length of the header, that is known as a total length. Okay. Simple. And total length, the minimum size is 20 bytes. That is when you have no data. Maximum size is 65,536. That's the highest value you can create with 16 bits, obviously, because how do you say 16 bits? Because total length is 16 bits, right? 16 bits. If all the 16 bits are, checked to 1, 2 power 16 will be 65,535, 536. Okay, 0 to 65,535. Identification. Now, what is an identification? Now, you already know when an IP packet enters a router. Let's say you have a router. Hey, cancel. Let's say you have an IP packet entering a router. Okay. A router realizes that this IP packet is very huge and it has to be fragmented. Fragmented in the sense cut into multiple pieces. Now, when you cut into small packets, when you cut a big packet into small packets, identification is nothing but a number which identifies, it's a 16-bit number. Identification is a 16-bit number. Okay. All the packets which are fragmented are given the same number just to ensure that, just to clarify that these all 4 packets belong to the same big fragmented packet. Just to tell us that it's a 16-bit identification number to identify which packet they belong to. That is about the identification. Next, what are the flags that we see? As you can see, you have a 3-bit flag also. After 16-bit identification, you have a 3-bit IP flag. There are just 3 flags. The first one is always set to 0. It's reserved. It's used for reserved purposes. The second bit is called as a do not fragment. If that is set to 3-bit flag. So how can you write the flags? If you have a 3-bit flag, 0, 0, 0, 1, 1, 1, 0, 1, 0, 0, 0, 1. Okay, these are the 3-bit flags. First one will always be set to 0, 0. If the second one is set in the sense 1, means it says do not fragment this packet. Do not fragment the packet which is coming in. If the third one is set more fragment, it means please fragment, go ahead and fragment the packet. That's the usage of these flags. Okay. Fragment offset. What is a fragment offset and how many bits it is? It is a 13-bit. Fragment offset is a 13-bit. Okay. 13-bit fragment offset. Why is fragment offset used? So when you actually break the IP packet into pieces, you should know which IP packet is in which position. Which IP packet is in which position. This 13-bit fragment offset tells us the position of the fragment in the original fragmented IP. It tells us the position. What is the time to live? Time to live, as everybody knows, I mean, even though who is not technical nowadays, they all know about time to live. They know that every time an IP packet comes to a router, the time to live is reduced by 1. If it is 0, then a router will discard that packet. If time to live is 0, then a router will discard that packet. Now, why this time to live was made? If the time to live was not made, the packet did not have any limitation, the IP packet would be roaming. Even the router discards, it will be roaming in the network. It has no time, right? I mean, it has no limitations. It will keep roaming in the network. So to avoid this routing loops, a time to live for a packet was invented, and the maximum value of 255 will be assigned. The maximum value is 255. It is a 8-bit field. Okay. Every time it encounters a router, the time to live reduces by 1. That is the funda. Now, what is a protocol? Protocol, this is an 8-bit protocol, 8-bit field. This 8-bit field tells us what protocol is encapsulated, what upper layer protocol is encapsulated in the IP packet. For example, TCP or UDP. What upper layer means? You have also read the ISO layer, I mean OSI model. In the OSI model, you saw that above the internet layer, you have a transport layer. In transport layer, you have 2 protocols, UDP, TCP, right? TCP is reliable, UDP is not reliable, right? These protocols have a protocol number. TCP has a value of 6, UDP has value 17. So which upper layer protocol? That is stored in the protocol field. What is header checksum? Header checksum is simple. Now, when you send this IP packet, you're sending this IP packet, imagine. A source is sending this IP packet. Okay. This IP packet is going to another router. Before it is going to another router, the sender, what it does, it using an algorithm, it calculates the checksum of this header. Okay. And it stores it in the header checksum. After reaching the destination router also uses an algorithm and calculates the checksum of this header. If that checksum calculated by the destination matches this one, which is in this field, then the header is not touched by anyone, it is not tampered by anyone. It is correct. Okay. So there is no errors. That is the way it verifies if the packet is being touched or not, or the integrity is good or not. Okay. Source address, obviously the sender will have a source address of 8 bits into 4 fields, that is 32 bits source address, 32 bits destination address, wherever you want to say. Options you would use it rarely. It's a variable length. Okay. Normally in the source root, for example, I'll show you the source root where the option is used on the labs that we do. This is the Wireshark capture of a packet. If you can see, as you can see all the fields here. Version is 4. I mean, I know it is a repetition for few guys. Maybe few guys are into CCNP level, but for few guys who are looking for CCNA, this would be helpful. So please bear with me, guys. Version is 4, header length 20 bytes. This is DSCP field, differentiated services field. Total length, identification, fragmentation, time to live, protocol, header checksum. So you see a checksum value here. Source address, destination address. You can find the source address here also, destination address here also. And you can see the upper layer protocol also. What is the port number? What is the sequence number? Okay. These are the things that we have in an IPv4 packet. Okay. So in the network fundamentals chapter unit, We actually finished the IP today, IP protocol. The next we have around, we have ICMP protocol. We have some other protocols like that, which I'll be discussing in the next class. So in the next week, we'll actually be discussing. Actually, let me actually tell you the concepts that we have for the next week. So today we went through about IPv4 packet. In the next class, we'll have some discussions about ARP. Then we have TCP, UDP. Okay, we'll talk about the TCP headers, TCP window scaling and all that. Then we'll talk about a small introduction about ICMP, DNS, and we'll get into the command line interface of the devices that we have. Okay, that covers the network fundamentals. After network fundamentals, we know that we'll be moving to network access. In the network access, obviously, what do you know about the access layer? You have switches, routers, and all that. So in the switch router, what do you find? You have LAN, VLANs, trunks, spanning tree, wireless. We'll discuss about that network access. Okay. Thanks a lot, guys, for joining today. Thanks a lot for your time. So please let me know if you have any doubts. I still have time. Please, you can actually talk to me and
Yeah,
you can.
Rahul,
Yeah.
just wanting to ask, is this course like, are these topics for the ENCORE exam, or are
We
these the
have.
topics for?
So what I'm doing is I'm just starting off with CCNA and actually going from CCNA to CCNP. So whatever topic that I take will be from starting with CCNA and it will be ending with CCNP topics.
Okay, so like in the
For example,
these units are with regards to both CCNA and CCNP.
that's right. So some of the topics I have not added, which belongs to NCore. I have to add them yet. So these topics are purely from CCNA. Okay, just to start off, I'm using these topics, CCNA topics, just to for those who are newly into this training, they have to go through some CCNA concepts, right? So for that purpose, I'm just going through CCNA. Once we start with CCNA, any topic like ether channel or VLANs or whatever, inter VLAN routing, we'll start off with CCNA, but we'll finish all the CCNP labs also along with this, with CCNP Encore portions. And not to worry, all the CCNP Encore, all the portions coming to 350-401, everything will be covered. Okay, all the CCNP courses will also be covered. I have for CCNP certification, Encore certification, I have created some topics also, which includes, I mean, same exam topics, whatever you find it in Cisco learning.cisco.com, you can see that. Switching, routing, wireless, multicast, network architecture, security, virtualization, automation. So we would be covering all of them, okay, in CCNP, NCore, and NRC. Okay.
And how long is this training supposed to be? Like, how long is it? When do you expect this to be completed? Like 3, 4, 5 months?
I think
Because
it would be, I think it 3 months or 3 to 4 months would be sufficient. I think I'm confident about 3.5 months itself. But depends upon the learning as well. So yeah, go ahead.
It will be a regular weekend.
It would be a
Uh,
weekend
it
batch.
will
Weekend 10:30 to 12:30.
so it will take 3 to 4 months weekend.
That's right. So just four times in a month you will be meeting each other. So I'll try to cover most of the topics. So whenever you guys have free time, I can extend from 2 hours to 2.5 hours as well, if you guys are interested, because concentration is more than anything. So let's see how it goes. So I will discuss all the
That will
topics.
be a Saturday, Sunday, right? Weekend will Saturday, Sunday.
Yes, exactly. Saturday and Sunday.
Again, 8 days in a month.
8 days in a month. That's right.
And the session will be of 2 hours or
Yeah, 2 hours. Initially, I'm just keeping it to 2 hours because I just don't want to bore you guys. So I'm just keeping it to 2 hours. So if you're okay with it, I can while I mean eventually we can extend.
This 10 units, which is belongs to CCNA. So how many
Exactly.
weeks it will take to complete?
So for now, we already had network fundamentals covered with only two topics left. But I would say that these three are big topics: network access, IP connectivity, IP services. Okay. So this would take about maybe 3 to 4 weeks. After that, I think these are quite easy. So I think this 1.5 month to 2 months.
Okay, got it.
Mhm.
and how about the labs?
So as and when we discuss any topic, we'll be doing the labs immediately, right? Right then.
And would you be adding
Uh,
the workbooks for those labs and
Exactly.
like in
Exactly.
okay. Is there a Discord channel for the CCNP batch? Because
Yes,
usually we have a Discord channel for Firewall. I asked
definitely.
Sagar, but he has just given the Zoom link
Yes, sure.
on
So
both
these are
occasions.
just two free classes, right? So after this, he'll be creating a Discord class, Discord group, and he'll be adding you and me into that. Maybe from
what is
next.
that Discord?
Discord is a type of messenger that we can use internally within us.
Or just like the Teams which we are using in our
Exactly.
office?
Exactly. Like Teams, WhatsApp, you can do a group chat over there.
So there is a course for that as well.
Sorry?
No, actually, I'm not getting what you are talking about. Discord
Discord
is
di-
it is a
di- Discord is an application where you can message everyone in the group. So for each batch, just like your WhatsApp group, you have a Discord application where you can use to message people.
no, so there is a course for that
No, no,
application
no.
as well, or you're
No, no, no.
something
There is
else?
there's no course. Let me show you how the Discord looks. So it is like this. Okay? Able to see my screen? So this is a just messenger app. I'll
Yes.
be sending you the Zoom link over here. And if you are the participant here, if you are a member here in this, you
Okay,
can
okay, okay.
access.
So means if I register for the course, then you will add me in that
Exactly.
Discord group, and we will communicate over there.
You got it. That's right.
Okay, okay, okay. So
Mhm. Any other questions, guys? Are you all good?
Thank you.
in a
Thank you, Rahul.
CCNP, you showed some branches, I think, like data center and some other topics are there. So in which are we going to cover in this CCNP?
The data centers? Are you talking about?
No, yesterday you showed some branches for CCNP branch. I don't know branch or a flavor or that data center and security and some other
We are
some
covering
seven
routing
to
and
eight.
switching here.
Only
Routing and
covering the
switching.
routing and
That's right.
okay.
So if you know routing and switching, we can proceed further. So it is like kind of foundation.
Sir, can I get this PowerPoint file?
Definitely. So once we are done with all the training, I will be sending the PowerPoint to everyone. Okay.
Okay.
Because I have to still add the diagrams and all that in this PowerPoint still. Once I finish adding the diagrams and also some convenient diagrams and all that, I will be sending to everyone after this training. Okay. All right, then I think there is no other doubts from anyone else. Syed?
Yeah, this is out of topic. Sorry to
Yeah,
ask.
sure.
Are
Go
you
ahead.
running any ASA firewall training, Mr. Rahul?
Right now, as of now, I am not, but I can start off depending upon the number of people. I can start off. So, are you interested in ASA firewall training?
Yeah.
Okay. Okay. So what I would do is you can just reach out to my team. Okay.
Hmm.
They have actually posted they you can WhatsApp them also. They'll be every time ready to reply you. So
Hmm.
you can ask them. So depending upon the number of people, we can start off with firewall training. Okay. ASA firewall,
Okay.
we can get started also in the next month,
Okay.
maybe.
Yeah. So
I'm sorry.
currently you don't have any registration.
Yeah, currently there is no none like that, or I don't know if there is anything going on in the back end also. But
Hmm.
you can just my team will let you know actually.
Okay. No problem.
Okay,
Sorry to ask you this question.
no worries, no worries, not at all.
Okay. Fine.
Thank you.
Rahul,
For
sorry,
that
one last
firewall,
question.
like,
I
Go
have
ahead.
one question, Rahul.
Yeah.
Regarding the CCNP,
Hmm.
are you going to cover anything on Cisco ICE engine and the other topics, some topics related to CCNP security when we talk about the
So
security
in
fundamentals?
yeah in
Actually,
security, so we'll talk about this AAA.
mhm.
And when it comes to infrastructure security, we'll talk about access list and COP, control plane policing, and all that. And we have wireless security. We'll talk about wireless security. Coming to network, network security, design components or network security. There we'll talk about this one, IPsec, router security policy, zone-based firewall kind of, then cloud security implementations policy, MAC and
Anything on
bypass.
ICE? Anything on ICE?
ICE in the
Cisco
sense,
ICE.
can you ping me that?
Cisco Identity Services Engine.
Cisco Identity Service Engine.
Used for identification management, authentication. I don't think so. It will cover
Yeah.
in. It's a different
Okay.
topic altogether.
Okay,
Yeah,
because
I think it is part of CCNP,
so
the
if
security
No,
concentrator.
we can do one thing. So if most of them are interested in that topic, we can actually take a different session for that, or maybe after finishing this training, we can have one more class, maybe just for 1 hour or 2 hours, and we can finish that concept also. We can talk about that also, discuss about that.
Yeah, actually, I'm already a CCNA, but I'm looking to get my CCNP. I'm
Uh-huh.
also doing the firewall, FortiGate firewall training from Network
Awesome.
Journey already. But
Awesome.
my company requires me to pass the CCNP certification, and that too with concepts around the Cisco ISE, because I'm working uh, extensively on Cisco ISE, Cisco DNS Center, and
Oh,
things like
awesome.
this. So if you can actually cover these
Awesome.
topics, what it will do is I can reinforce these, and then when I'm working with the projects, that will help me
Well, in that case,
because
Mrugank, what I'll do is you actually write down the topics that you need on the notepad. Just send it out to me. Okay. Maybe if I know some of the concepts, that is well and good. If not, I will make sure that I'm at least knowing those maturely by the time we finish the training, and I'll try to explain that topic to you. We can discuss about it. Okay. We can together work on it.
sure. Thank you.
No worries. No worries. All right, guys, if that's the end of doubts that you have, thanks a lot for your time today. Have a very good weekend, guys.
Thank you.
Thanks
Same
a
to you.
lot. Bye.
Thank you,
Bye.
everyone. Bye.
Bye.